Hello everybody, welcome to our lesson. Today we will solve a problem on the topic self-induction and inductance. This is the goal of the lesson. At the end of the lesson, you'll be able to use the equation for the self-induced EMF, use the equation for the inductance, and find inductance of a solenoid. Now, as always, before we start, it will be useful to recall the equations from the previous lessons. So this is the equation to find the self-induced EMF of a solenoid or any other conductor. And to find the inductance of the solenoid, you must multiply mu0 to the n squared and to the volume. So that's it. Now let's go to the problems. So this is the first problem. First of all, let's write the givens. So EMF produced is 2.5 volts and the inductance it is 0.5 Henry, and current rises uniformly from 0 to I. So it means I1 is I, and let's write initial and final. I final, initial is I, 0, final is I. It rises from 0 to I. And the time is, the interval of time is 0.1 seconds. And we need to find the value of this I. So we have an equation for the self-induced EMF, and by putting the values into this equation we found current. So 2.5 is equals to minus L is 0.5, and delta I is final minus initial. It is I minus 0 over delta T is 0.1. So here we can cancel 0.5 and 0.1. So it is 5. And I is equals to 2.5 over 5. And we also can cancel this. Here we have 1, here we have 2. So as we see, the current is minus 0.5 amperes, and minus is only a reminder for the direction of the current. And if we're asked to find only a magnitude, then we can say that the current is 0.5 amperes. So that's it. This is the first problem, and let's move to the second problem. Here we're asked to find the turns of wire, how many turns of wire we have. Before we find this, let's write what we know. We know that the inductance it is 300 millihenry, and we know that the length is 0.2 meters, and we also know the diameter, it's 0.08 meters, and we're asked to find the number of turns. So the inductance of the solenoid can be found by this equation, and N here it is the turns density, it is N over L. Then V it is area times the length of the solenoid. If we put it into this equation, we have this kind of expression, N over L squared times A times L. And if we take the square, we have n squared L squared times L times A. I've just replaced the L and A. So the L here can be cancelled and we have this kind of equation. L is equals to mu 0 n squared A over L. So this is one way of finding inductance of a solenoid, and we can also consider this as an equation. So you can find either in this form the inductance of a solenoid or in this form. So result will be the same. Now let's put the numbers here. This is 300 millihenry, it is minus 3 equals to 4 pi 10 minus 7 multiplied to a number we don't know, and the area of the circle is pr square, or it is pd square over 4. So we just put here p and d, it is 0.08 squared and over 4, and also divide it to 0.08. Okay, now all we need to do is calculate this. Okay, let's write. This is 10 to the power 2, this is minus 3, it will be minus 1. So we have here 3 10 minus 1, and it equals to, here we can cancel this 4 and this, also we can cancel this and this, and what do we have? Pi, here we have 1 pi and here second pi, we can say pi square times 0.08 times 10 minus 7 and times to the n squared. And let's be sure that we haven't missed anything here. So it seems we haven't missed anything. Okay, what do we do next? N squared is equals to 310 minus 1 over pi squared 0.08 divided 10 minus 7. So it is, so we have minus 1 here and minus 7, means we have minus 6. And we do what? If we consider the p as 3, then this will cancel out and we have just 3 here. And it means 1 over 3 times 0.08 times 10 minus 6. And the answer is, let's calculate the answer. Wait, I think we've made a mistake here. Here the L length, it is not 0.08, it's 0.2. We've made a mistake here. So we can't cancel this. And what else? 4 can be cancelled here. It is 0.08 squared 0.08 squared over 0.2. And what else? So it means here 0.08 squared times 0.2. Now I think we can calculate. Okay, if we calculate here, we get n squared is equals to approximately 10.42 10 to the power 6, and if we take the root of it, the answer is 323 10 to the power 3. So it is n 3230. Approximately we need 3200 turns to have 2.5 to have 300 millihenries. Now let's go to the third problem. So what we have here, let's write the given. We have solenoid, 10 centimeter length of solenoid, and has a cross-sectional area 5 centimeters square. We can write it 5 10 minus 4 meters squared. And what we also have, we have number of turns. This is 3000, but that's not number of turns actually, that's the turns density, because 3000 turns per meter, meter minus 1. And in A part we need to find the self-inductance, and at the B part we need to find the self-induced EMF. And if the current is changing from 1 ampere to 3 amperes in an interval of time delta t is 0.1 seconds. So that's all we have. Now let's find self-inductance and the induced EMF. A part. In A part we are going to use this equation, mu 0 n squared A over L. And let's just do the calculations. This is 4 pi minus 7. Okay, I think it will be more convenient if we use this equation. Now the L will be equals to 4 pi 10 minus 7 multiplied to 3000 square. Volume, it is area times the length. It is 0.1 the length times to the area, it is 5 10 minus 4 meters square. So we have what? 4 times, let's assume this is 3 10 minus 7. This is 3 10 to the power 3 squared. Here we have 5 10 minus 5. This is 10 minus 1 actually. Okay, what we have? 12 times 10 minus 7 times 9 10 to the power 6 times 5 to the power 10 minus 5. And I'm going to write the numbers first and then the powers, 10 to the power 6, 10 to the power 5. So we have basically 12 times 9 times 5, 12 times 9 times 5, it's 12 times 45, then it is 540. 10, this is minus 7 plus 6 plus 5, minus 7 plus 12, then this is minus 5, I suppose. No, 5, just 5. Minus 7 plus 6, it is minus 1. Minus 1 plus 5. Sorry, this is minus 7 plus 11, not 12. So that's why it is 4. And we can write as follows. Finally, it's 5.4, 10 to the power 6 Henry. Oh, sorry, here we have minus 5. Sorry. Minus 7 minus 5, it's minus 12. Minus 12 plus 6, it's minus 6. Here minus 6. And the answer here is 5.4, 10 minus 4. And we can rewrite this as 0.54 millihenry. Okay, now B part, we need to find the induced EMF. This is minus 54, 10 minus 3. This is the inductance. And the changing current, it's 3 minus 1. Changing current, 3 minus 1. The interval of time is 0.1. And what do we have? Minus 0.54, 10 minus 3, 2 over 0.1. So 2 over 0.1, it's 20. And if we multiply all this, we get equals to minus 27, 10 minus 3 volts. So minus 27 millivolts. Now the fourth problem, and in fourth problem we see an equation here, t squared minus 6t. So current changes by this equation. And we also know the inductance, it is 90 millihenry. And we have an equation of the current which changes by time, t squared minus 6t. And we're asked to find in A part the induced EMF when time is 1 second, and in B part we ask to find induced EMF also when time is 4 seconds, and in C part we are asked to find time when induced EMF will be equal to 0. So now what we do here, we know that the induced EMF will be change in current over change in time. So the key thing is to find change in time, change in current, sorry. It is current minus the final current minus the initial current. So initial current, it is when it is 0 because time is 0. From the equation we know that the initial current is 0. And how to find the current when the second is 1 at first second? We just put into the t, instead of t, 1 minus 6 times 1. So 1 minus 5, we have minus 5 amperes. And change in current is minus 5 minus 0, minus 5 amperes also. Now let's put it into the equation. Minus 90, 10 minus 3, this is the inductance, minus 5 over the interval of time is 1. So what we have here, minus and minus will cancel each other out. We have 450 millivolts. B part, again, we need to find the change in current. It is final minus initial, and initial current again here is 0. So we need to find the current at the 4th second. We just put the 4 instead of the time. 6 times 4 and 16 minus 24 minus 8 amperes. And changing current, we see minus 8 minus 0, also minus 8 amperes. And now let's put everything into the Faraday's equation. 10 minus 3, changing current is minus 8, and interval of time is 4. So we have here minus 90, 10 minus 3 times minus 2, because minus 8 over 4 is minus 2. So the answer is 180 millivolts. And at C part, so the induced EMF is 0 volts when changing current is 0. So it means that our equation t squared minus 60 must be equal to 0. And this is possible in two situations. So from the equation we see that the EMF will be 0 at time when time is equal to 0 and at time when time is equal to 6 seconds. So in these two instead of time we have EMF equal to the 0. Now this is the last problem. Again, let's write the givens here. What do we have? The number of turns is 420 and the length is 0.16 meters, and we have the rate of decrease of current. It is delta I over delta T. Decrease, it means it will be minus 0.421 amperes per second. So we have an induced EMF, it is 175 millivolts, and we need to find the radius of the solenoid. Okay, now let's start from the Faraday's law. Delta I over delta T, and the induced EMF is 175 10 minus 3, and we don't know what is inductance, but we know the rate of change of current is minus 0.421. Now here L is equals to 0.175, because it is 175 over 1000 over 0.421, and minuses can be cancelled out, so I'm not writing the minus here. Now if we calculate this, we get L is equals to as approximately 0.373 Henry. Now we found the inductance, and by this we can find by this equation we can find here area. How can we find area? Let's put the numbers. So L, we know it is 0.373, and it is 4 pi 10 minus 7. Number of turns is 420, area we are going to find over the length, it is 0.16. So what we have here, 0.16 and 4 can be cancelled out, so this can be cancelled, it is 0.04, and let's calculate the area here. Area is equals to 0.373 multiplied to 0.04 over pi, it is 314, 10 minus 7, here I forgot the square, 400 and square. So if we calculate 0.373, so let's calculate. Wait a minute, I will use a calculator. So the answer is 0.269 meters square. You can check it by yourself using a calculator. And now, if we know the area, we can find the radius. So 0.269 is equals to 314 times radius squared, and the radius square is equals to 0.269 over 314, and it is, again by a calculator, we found that this is 0.0858, and if we take a root of it, we found that this is 0.203 meters, and the final answer for the radius approximately 29.3 centimeters. So that's it. This is the final problem. Well, this is the end of the lesson. I hope you've enjoyed solving problems with us. If you like our video, please subscribe and share. Thank you.